Hello, and welcome back to Chapter 8's lecture on complex designs. This is going to be the basics of factorial designs, part 2. In this, I want to start by talking about how we start to look at the effects that are happening with our groups and levels. When you have a factorial design, keep in mind that the number of levels that you have doesn't really matter all that much in terms of the design, except for when you're looking at how do we analyze or compare the results of each of these levels. One of the things that you have to do is you're going to look at what's called a main effect. And a main effect is looking at all the statistical variability or mean differences that are related to that one independent variable. If you have two independent variables, you will also have two main effects, because the total number of main effects that you're going to be investigating is equal to the number of independent variables that you have. Now, in addition to a main effect, you're going to have to look at something called an interaction. And the interaction is the part that actually researchers are most interested in. This is that joint simultaneous effect of more than one independent variable on your dependent variable. So, for example, if we are looking at effectiveness of therapy versus drugs on depression, well, we may care just for the main effect to see how the main effect of therapy type affects depression. We can also look at the main effect for our drug therapy on depression. But what we probably most care about is the interaction. What happens when we put drugs and therapy together? Does that better help people with their depression symptomology? And does it do so above and beyond just drugs alone or just therapy alone? Another consideration that you'll have to make when making a factorial design is how to get your participants into your groups. There are 3 ways of assigning participants to groups, of which we've talked about 2. Between subjects designs, where our groups are completely independent of one another. Within designs, where essentially everybody is in all of the conditions, so they are correlated groups. We also have a new way of getting participants into your groups, and that is with what we call mixed assignment. And this means that at least one of your independent variables has that between subjects comparison. It has that independent groups. The other independent variable has that within subjects comparison, that is, those correlated groups. So it's called mixed because we have between and within all in one experiment. So let's take a little bit deeper dive into each of these methods for assigning participants to groups. Random assignment, as you know, you're going to have a true random procedure for getting participants into groups. These are typically called between subjects designs or sometimes called completely randomized designs. Now, if you have one where you have random assignment to groups, but one where we do not, well, that's the mixed assignment to groups. This is, again, that mixture where one independent group and one correlated group for each of your variables. If you have more than 2 independent variables, at least one of your independent variables is independent groups, and at least one has correlated groups. When we talk about the design type here, we would say this assignment to groups is mixed groups. Now, as you know, of course, we also have within subjects designs, that is non-random assignment to groups. This is where all of our subjects are within all of our levels of that independent variable. We may want to do this in order to assume the equality of our groups before our experiment is conducted. Another method of having non-random assignment to groups is to have repeated measures. And this is where participants would take part fully in all levels of our experiment. So in this case, this is what we've thought of as within subjects design up until this point. If you have lots of independent variables or you have lots of levels of one independent variable, it can be really hard to get participants to stick around and be reliable participants in all those conditions. So the smaller the design, the more feasible it is to actually include a repeated measures participant design in your experiment. Another method of using non-random assignment to groups is using natural pairs or sets. This is where we may use an existing pair or existing triplet or quadruplet in order to try and keep a confounding variable out of our experiment. So for example, if we use natural groups in a totally within subject's design, we will have to have, let's say, one twin in one part of our experiment and the other twin in the other part of our experiment. Now you may be thinking, well, that's two different people, so that's a between subjects design. But if what we're trying to control for is something like genetic diversity, putting one twin in each group would allow them to experience different conditions, but would also keep the genetic diversity low because they would have almost identical genetic background. And we call this a non-random assignment to groups because you are essentially putting the same genetic person into both groups, even though it's obviously two different people. The problem with this is that it becomes harder to find an adequate number of naturally linked participants. This is most commonly used within lab studies where we can control genetic diversity within litter mates or pup mates. Another type of non-random assignment to groups would be something called matched pairs or sets. Matched pairs or sets are where we actually take some confounding variable. Let's say intelligence is a confounding variable in the study that we're doing. And so we would measure all of our participants on intelligence ahead of time. And then we'd see all those people who actually have the same intelligence level. And we would put one of each of those pairs within each component of our experiment. So for example, if you have two people who have an IQ of 110, you'd put the first person into one group and the second person into the second group. Now what you've done is you've controlled for a level of intellect, but you don't have to have the same person in both groups. The trick with doing a matched pair or matched set is you have to be very precise. You have to clearly identify the variable that you're controlling for, and you have to make sure that the match is close enough to actually properly control that variable. Let's turn our attention from assigning participants to looking at other variations of factorial designs. Up until now, we've been talking about the 2x2 factorial design, where we have two independent variables, each with two levels. Well, you may, for a variety of reasons, want to do a 3x2 factorial design, where you still have two independent variables, but you have a third level on one of those independent variables. The thing you have to keep in mind here is now this is going to require 6 groups rather than 4 groups. Every time you add a level to your factorial design, you've increased the complexity of your design exponentially. Therefore, it makes sense that when you're considering using a factorial design to be practical, use the bare minimum number of levels and independent variables that will adequately answer the question you have in mind. Be parsimonious. Thank you for your attention.